Hello students, this is the recording for lesson 2.02 and we're going to be going over chemical bonds. So here's the overview of what we'll be going over today. We're going to be going over different types of chemical bonds. So we'll be talking about ionic bonds, covalent bonds, and hydrogen bonds. We're going to talk about the differences between all of these bonds and some examples of each. The goals for this lesson is that you'll be able to explain what an ionic bond is between atoms, a covalent bond, and a hydrogen bond between atoms. And also, at the end, we will be talking about how matter tends towards disorganized states, which we're going to call entropy. Okay, so let's just go over what bonds are in general. So atoms form bonds by either losing, gaining, or sharing electrons. In the last lesson, we talked about protons, neutrons, and electrons that are present in all atoms. When we talk about bonds, we talk about the relationship between electrons between different atoms. So a chemical bond is a force that's going to hold atoms together. When two or more atoms bond together, they're going to form molecules. So again, molecules are just when two or more atoms come together. To understand how atoms bond, again, you need to know more about what an electron is. So when we talked about the structure of an atom, we talked about how there's a nucleus in the atom. In the nucleus, we have protons and we also have neutrons present. Electrons are not found in the nucleus of an atom, but they are actually moving around the nucleus. So we see these blue little balls that are circling around that nucleus are what we call electrons. And more specifically, the electrons that are in this outer level, so this outer ring of the atom, we're going to call them valence electrons. And the reason why it's important that we know what valence electrons are is because when bonding occurs, it's the valence electrons that are losing, gaining, or sharing electrons with other atoms. In this example right here, we see sodium, and if we look on that outer level of this sodium atom, we see that it has one valence electron. And so again, we're going to be looking at different atoms and the different amounts of valence electrons that it has and how that plays a role in the type of bonding that it participates in. So the first type of bonding that we're going to look at is ionic bonds. Ionic bonds form between positively and negatively charged atoms. And so, as you probably already know, positively charged molecules are going to be attracted to negatively charged molecules. So opposites attract. Remember, we went over in the last lesson what an ion was. And an ion is basically an atom with an electrical charge. And how an atom actually gets an electrical charge is if it either loses or gains an electron. Okay, so if it loses an electron, that means it's losing part of its negative charge, and so it becomes more positive. If it gains an electron, if an atom gains an electron, then it's gaining a negative particle, so it becomes more negative. Either way, if an atom becomes more positive or more negative, it has an electrical charge, so we call it an ion. When two ions interact with one another, they're obviously going to be attracted to one another because one is positively charged, the other one is negatively charged. So we have a good example of an ionic bond found right here between a sodium atom and a chloride atom. Together they're going to make a sodium chloride molecule. So we see here that the sodium atom has one valence electron right here, and the chloride molecule has 1, 2, 3, 4, 5, 6, 7. So remember, in an ionic bond, it's going to be a bond between two ions. So there must be one molecule losing and the other one gaining an electron. So what's going to happen here is if you look at what it looks like after an ionic bond is formed, we see that the sodium actually gave an electron to the chloride, right? So we no longer see that one valence electron on the outside, but chloride now has 8. And so because chloride gained an electron, we see that negative charge, and because sodium lost an electron, we see a positive charge. This will then cause an attraction between the two atoms, forming an ionic bond. So the main thing you need to remember about ionic bonds is that it's a bond formed through the loss and gain of an electron. The next type of bonding we're going to go over is called covalent bonds. Covalent bonds are different than ionic bonds because they form when atoms share electrons. So it's not one losing and the other one gaining, but it's actually the atoms are going to be sharing that electron. And this is actually the strongest type of chemical bond. This shared valence electron binds the atoms together. A single atom can form covalent bonds with several other atoms at a time. One example of this is actually a water molecule, which we see right here. So in this example, we have two hydrogen atoms, which are down here, and we also have one oxygen atom. If we look at the hydrogen atom, it has one valence electron each, and then the oxygen actually has 1, 2, 3, 4, 5, 6 valence electrons. So what happens is that this hydrogen valence electron will come in contact with the oxygen atom, and we see that in the end, we see a sharing of the valence electrons. Once these electrons are shared, a covalent bond is formed, and that's how we get a water molecule. The chemical formula for a molecule of water is H2O, which shows you that there are two atoms of hydrogen bonded to one atom of oxygen. Let's go ahead and take a look at the water molecule a little bit more closely. So when hydrogen bonds with a larger atom, in this case a larger atom would be oxygen, right here, the electrons are shared unevenly. So do you know the game of tug of war? Imagine the covalent bond between hydrogen and oxygen as a rope in a tug of war, and each side is pulling to win over their shared electrons. So these are the shared electrons that we're talking about right here. Okay, so hydrogen has one proton, right? And so it has like a positive charge, right? The protons have positive charge and they have one of them each. Okay. Oxygen, on the other hand, has 8 protons in its nucleus, right? So it has a much more stronger positive pull in its nucleus. So remember, these electrons are actually negatively charged. So in this game of tug of war, the oxygen's nucleus has a much stronger pull because it has many more protons in its nucleus to pull these electrons closer to the oxygen molecule and further away from the hydrogen molecule or hydrogen atom. Because these electrons are getting pulled away from the hydrogen atoms, what you see is that the hydrogen in the water molecule ends up being slightly positive because again, they're kind of losing, or the electron is being pulled away from the atom. So these are slightly positive, but the oxygen atom, because the electrons are becoming closer to its nucleus, it's actually becoming slightly negatively charged. And that's kind of what these symbols mean. It's a partial negative and a partial positive. It's not a full positive charge because the hydrogen still has those electrons, but because it's closer to the oxygen, it's partially positive. The last type of bonds we're going to talk about in this lesson is hydrogen bonds. So a hydrogen bond forms between molecules, and it's actually one of the most weak bonds out of all the chemical bonds. So one example is if we look at the water molecules one more time, we have like one, two, three separate water molecules interacting. We're going to take a look at how they would interact with one another. So remember we said that the hydrogen molecules here were slightly positive and the oxygen molecule is slightly negative. And we see that denoted in each of the water molecules. So a slightly negative oxygen atom would attract a slightly positive hydrogen atom when water molecules are interacting with one another. A hydrogen bond is an electrical attraction between partially charged molecules, just like water molecules, that contain hydrogen atoms. Hydrogen bonds, again, are pretty weak compared to ionic and covalent bonds. So what you see here is that these three water molecules, how they could interact is this this negatively charged oxygen right here can interact with this positively charged hydrogen. And maybe another example would be this negatively charged oxygen can interact with this positively charged hydrogen. And so what you see here is interaction right here and interaction right here. And so even though it's not um, a strong bond, there is an attraction because of those partial electrical charges. But again, the hydrogen bond is a lot weaker than the covalent bonds and ionic bonds that we talked about previously. So even though we talked about bonds and how the chemical world is building on itself to become more and more organized in molecules, there really is a flip side to this process. A lot of matter starts out or becomes part of a precise and neatly built unit, such as a butterfly or tree, and bonds have a lot to do with that. However, over time, many of those things will die, rust away, or fall apart. All biological organisms decay and decompose and get broken down. Over time, all organized matter such as a butterfly, tree, car, genes, really anything that you can think of tends to become unorganized. This concept is actually called entropy. Another way to understand entropy is if you think about a deck of cards. If you threw an entire deck of cards into the air, the chances that it would actually land back in one neat stack is pretty much impossible, and matter is very similar way. Everything in the end tends to go towards an unorganized state, and we call that entropy. So an example again, it would be there'd be healthy trees, lots of chemical bonds that allow this to occur. Eventually, though, all biological organisms will go towards entropy, which is an unorganized state. So eventually it'll die and decay. So here's a summary of what we went over today. We went over different types of bonds, right? We went over ionic bond and how this forms when neutral atoms lose or gain electrons. We have covalent bonds, which is when neutral atoms share electrons. And we have hydrogen bonds when we have partially charged molecules attracted to each other. And our example was water molecules. And despite all of these different types of chemical bonds that we've gone over, remember at the end of the day, matter will always tend towards unorganized states or entropy. So here's some important vocabulary that you'll need to know. First, molecules, which is any compound resulting from covalent bonding, which is that shared electrons. Valence electrons, the electrons in any atom's outer orbital path. An ionic bond, which is the force of attraction between a charged atom or group of connected atoms and another with the opposite charge. Remember, positive and negative opposite charges attract. Covalent bonds, which is a bond in which electrons are shared between the bonded atoms. Hydrogen bond, which is the force of attraction between a partially charged atom and a hydrogen atom that is covalently bonded to another partially charged atom. And then entropy, which is the randomness of any physical system. Remember, that's when all biological organisms go to a disorganized state.